Hey friends, today we are starting our new science unit, and for materials you'll need your notes glued into your notebook and a pencil, and once you have those things, we're ready to go. So our I can statement as part of our new unit is going to be I can explain how matter changes when exposed to heating and cooling. And today's going to be an introduction where we talk about the different states of matter. We're going to be talking about solids, liquid, and gases, and how one state of matter changes to another state of matter. So we will go ahead and get started. So first thing is what is matter? Maybe it's a term you've heard of before, but matter is anything that takes up space, and that's going to include air, water, rocks, and even people are examples of matter. So in our notes, first thing we've got is matter is anything that takes up space and has weight. And again, anything you can imagine holding in your hand, whether it be a rock or a person or a cat, are all examples of matter. So there are three states of matter. Matter can exist in three different states. Those three states are liquid, solid, and gas. We'll talk more about each of these in just a moment. And so once you have matter in one state, it's not that it has to stay in that same state forever, but instead matter can change from state to state, and the way that it does that is through heating and cooling. So just as a real quick basic example, think about a glass of water. When you are drinking water, you're drinking it in its liquid form. If you wanted to make it colder, you would freeze it, and once water freezes, it turns into ice, which is your solid form of water. Or on the flip side, if you have a pot of water that's boiling, once it begins to, if you've noticed a pot on the stove before, you start to see the steam coming up, that's the water turning into its gas form of water vapor. So again, heating and cooling changes the state of the matter. So let's look at some examples of this. So before we do that, we'll come back to our notes. So thinking about a solid is going to keep a set shape, meaning it's not going to change while it's a solid. It always has one set shape. A liquid is going to take the shape of its container, meaning anything you pour water into, the water will form the shape of its container to fill it up. And then lastly, gas. Gas is going to float and fill its container. And we'll look at some more examples of this in just a moment. So let's talk a little bit more about the changing states of matter. So I said just a moment ago that heating and cooling can cause matter to change state. Let's start by thinking about heating. So adding heat means to increase the temperature, and you do that by using warmth, and it could be warmth from the sun, warmth from the stove or oven or a hot plate. It could be warming something up by putting it in front of a furnace or a fireplace, or even just putting it in a warmer room. And adding heat is going to make solids start to melt and change from solid to liquid, and then adding heat to liquids causes the liquid to begin to evaporate and change from a liquid to a gas. So let's look at some examples of this. So here we've got some ice cubes. The ice cubes are just sitting out at room temperature, and we've all seen this before. If you don't have ice in the freezer, it will begin to melt. And so it's going from solid ice to liquid water. So room temperature adds enough heat to the ice to melt them and turn them into liquid. Maybe you make toast in the mornings for breakfast sometimes. Well, if you have really hot toast and you add solid butter to your toast, the butter will begin to melt and turn into a liquid form. When we start thinking about really extreme heats, so really, really hot over a fire, you can even melt solids such as metals. Metals melt when exposed to really high extreme temperatures, and they go from a solid to liquid form. And then lastly, here's an example of taking a liquid and exposing it to really hot temperatures. So as you boil water, the pot of water is going to create steam as the liquid water begins to evaporate. And so the liquid water is turning into the gas form of water, which is water vapor. So in our notes, let's go ahead and summarize what we've done so far. Matter changes state when it is exposed to, and the first one we've talked about is heating. And then the next one we're going to talk about on the next slide is going to be when exposed to cooling. So matter changes state when exposed to cooling. And we'll look at some examples of this now. So going in the opposite direction, meaning to cool an object down instead of heating it, the heat must be taken away. So a couple examples. Placing water in freezer takes the heat away and cools the water enough to turn it into solid ice cubes. So you're turning a liquid into a solid. If you take a liquid like water and you change it into a solid, it takes very cold temperatures, and so we said in a freezer, but also sometimes outside, right? If it's really cold outside and we have a puddle of water, that puddle of water the next morning might be ice because it's frozen overnight because the temperature's dropped. And then when you start to think about other materials, for example, melted chocolate or liquid candle wax, those, when they are starting at a liquid form, so melted chocolate or a candle that's been burning the wax becomes liquidy, those become solid, but it doesn't take really cold temperatures to turn those back into a solid. It just takes kind of a room temperature to turn those back into a solid. So looking at those examples here, water is going to require freezing temperatures to go from a liquid to a solid, whereas candle wax that's been melted from burning it, or chocolate that's been melted in the microwave, or maybe just melted from your fingertips, those two are going to go back to a solid form at a much more mild temperature, or room temperature. But either way, by applying a cooling temperature, the liquid will refer back to its solid state. Okay, so to summarize here, we've got heating can turn a solid into a liquid, and a liquid into a gas. On the opposite side, cooling can turn a liquid into a solid and a gas into a liquid. And so back up here on the slides, just to wrap up, one thing that we do need to keep in mind is that not all matter is going to melt or, on the flip side, freeze at the same temperature. And some materials are going to require really, really hot temperatures to melt, or really, really cold temperatures to freeze. So, for example, you might say, hey, if I'm cooking breakfast and I'm making eggs, I'm going to cook my eggs on a pan. And when you put the butter on the pan, the solid butter turns into a liquid as it melts. But you might notice that the metal pan itself does not melt. And that's because metal is going to have a different melting temperature, a different temperature where it turns into a liquid than the butter. And so temperatures much, much higher than a stove are needed to melt metals. And again, this is just to remind you that not everything's going to melt at the same temperature. And in the same way, not everything's going to freeze or become solid at the same temperature. So for example, we saw this before, water, it takes really cold temperatures below freezing to turn water from a liquid to a solid, but then other materials like candle wax or chocolate can become solid at a much more mild room temperature. And here's an example to see that. So this little puddle right here, because it's such a small puddle, it could probably freeze quite a bit faster than, say, an entire lake. So in addition to considering the material, you also are going to think about the quantity of matter to determine how quickly or slowly it will change states by heating or cooling. So again, this little tiny puddle could probably freeze overnight because it's a small amount of matter going through that change. Whereas an entire lake, you can see this is by Chicago, Lake Michigan, it's going to take much longer for this entire lake to freeze because there's a much larger amount of matter. And so it might be below freezing, and it just takes one night for this puddle to freeze, but it's going to take much longer for this lake to freeze in entirety. So just to kind of summarize what we've learned today, we've learned that there are 3 different states of matter, solid, liquid, and gas, and that heating and cooling can cause matter to change state. And so the main takeaway here is that you'll notice heating going in this direction. We'll see solid turning into a liquid or a liquid turning into a gas, whereas cooling is going to cause gases to become liquids again, and liquids to freeze into solids. So both heating and cooling can change matter's state, but it's always going to follow the same direction. So gas into a liquid, liquid into a solid when exposed to cool temperatures, and when exposed to really hot temperatures, you'll see the solid turn into a liquid and eventually a gas. So finishing up in our notes, the last thing we're going to note here, we saw on the previous slide, is not all matter changes states at the same not all matter changes states at the same hot or cold temperature. Not all matter changes states at the same hot or cold temperature, so it depends on the material of the matter. And again, we've got this diagram here as a reminder. So heating in this direction, we're going to change from a solid to a liquid to a gas. When exposed to cold temperatures, we'll change from a gas to a liquid to a solid. So once you've got your notes complete today, you can go ahead and continue through your assignment.